We now discuss the solutions of the problems from the topic quadratic equations, which are given under multiple choice questions in the joint entrance examination main in the January 2024 session. So all those questions under the topic quadratic equations under multiple choice questions in this January 2024 session, we will answer all of them. These examinations were held from 27th January 2024 to 1st February 2024. We now go to the question number 1. And this question has appeared in the joint entrance exam main held on 27th January 2024 in the second shift. The given question is, if alpha beta are the roots of this quadratic equation, x square minus x minus 1 is equal to 0, and s suffix n is 2023 multiplied by alpha to the power of n plus 2024 multiplied by beta to the power of n, then we are given 4 options. All these options are: what is the relationship between S12, S11 and S10? We are given a quadratic equation, x square minus x minus 1 is equal to 0. We are also given alpha and beta are the roots of the equation, and we have Sn is equal to 2023 multiplied by alpha to the power of n plus 2024 multiplied by beta to the power of n, and required to find the relationship between S12, S11 and S10. Let's now discuss the solution of the problem in detail. We are given alpha and beta are the roots of this quadratic equation, x square minus x minus 1 is equal to 0. So if alpha is a root, alpha satisfies this equation. So alpha square minus alpha minus 1 is equal to 0. Let's call this as the equation number 1. So also beta is a root, therefore beta satisfies this equation. Therefore you get beta square minus beta minus 1 is equal to 0. Call this as the equation 2. Right. Look at the question. In the question, Sn is equal to 2023 multiplied by alpha to the power of n plus 2024 multiplied by beta to the power of n. That means we must get alpha to the power of n from the first equation and beta to the power of n from the second equation. How do we get it? This is already alpha square is there. Multiply both sides by alpha to the power of n minus 2 and the second equation by beta to the power of n minus 2. So we take the first equation. We take the first equation and multiply by alpha to the power of n minus 2. Then we will get alpha to the power of n minus 2 into alpha square is alpha power n minus alpha power n minus 1 minus alpha to the power of n minus 2. Call this as the equation 3. In a similar fashion, multiply the second equation by beta to the power of n minus 2. You will get beta to the power of n minus beta to the power of n minus 1 minus beta to the power of n minus 2 is equal to 0. Call this as the equation 4. Now it's very clear. Multiply the third equation by 2023 and thereby we will get 2023 into alpha to the power of n, and multiply the fourth equation by 2024 and then you will get 2024 multiplied by beta to the power of n and add. Then we will get this. We take the third equation, multiply by 2023 plus take this fourth equation multiplied by 2024. So these two things are added now. So add 2023 multiplied by alpha to the power of n plus 2024 multiplied by beta to the power of n, that is the first term, minus common 2023 multiplied by alpha to the power of n minus 1 plus 2024 into beta to the power of n minus 1. So minus here also 2023 multiplied by alpha to the power of n minus 2 plus 2024 multiplied by beta to the power of n minus 2 is equal to 0. And what is 2024 multiplied by alpha to the power of n plus 2024 multiplied by beta to the power of n? That will be Sn. Minus this second one, the second one in brackets is Sn minus 1. Minus the third, this one is Sn minus 2. So Sn minus 1 minus Sn minus 2 is equal to 0. This will imply Sn is equal to Sn minus 1 plus Sn minus 2. Now, so you have to find out a relationship between S12, S11 and S10. So that can be achieved by putting n is equal to 12. N is equal to 12. So put n is equal to 12 in this. We will get S12 is equal to S12 minus 1 S11 plus S12 minus 2 S10. So the relationship is S12 is equal to S11 plus S10. Not 1, 2. You have to read it as 12, 11, 10. So the relationship between S12, S11 and S10 is to be found, and this is the relationship. Let's look at our options. Our option 1 is precisely this one. So therefore, the answer to this question is option 1. So that is the detailed discussion of the solution of the given problem from the section quadratic equations. And I am sure that you have understood the solution of this problem, and we move to the next problem. And this problem has appeared on 31st January 2024 in the first session. Right. The given question is, let S be the set of positive integral values of A for which ax square plus 2 times a plus 1 multiplied by x plus 9a plus 4 whole by x square minus 3 minus 8x plus 32 is less than 0 for all x belongs to R. So then the number of elements in S is, we are given 4 options. So S is what? S is the set of positive integral values of A. Positive integral values of A means A belongs to the set of natural numbers. For how many values, positive integral values of A, this one is less than 0 for all x belongs to R. For all x belongs to R. Note down, for all x belongs to R. How many elements? How many elements are there in S? That means required to find n of S. We now discuss the solution of the problem in detail. We are given S. S is the set of all A belongs to n such that ax square plus 2 into a plus 1 into x plus 9a plus 4 whole by x square minus 8x plus 32 less than 0 for all x belongs to R. This is true. This should be true. Less than 0 for all x belongs to R. For how many values A belongs to n? Positive integral values. That means A belongs to n. Agreed. So now we want to find the number of elements present in S. It's the number of A belongs to n satisfying this one. Agreed. Now we take what is x square and we take, let's look at the numerator by denominator here. So in this denominator, the denominator, we want to cancel off. If we want to cancel off this one, that means if you want to multiply this one, we have to see whether it is always positive or always negative. If it is always positive, this less than will be retained. If it is always negative, this less than will become greater than. So let's take x square minus 8x plus 32 greater than 0. Yes, this is true. It is greater than 0 for all x belongs to R. Why? Why? Because the coefficient of x square, that is the leading coefficient, is 1 greater than 0, and its discriminant b square minus 4ac is computed here is less than 0. Is less than 0. Then in that case, this quadratic expression will be always positive for all x belongs to R. Let's recall. This is the result what you have studied. Let f of x is equal to ax square plus bx plus c, where a, b, c are real numbers and a not equal to 0. And if a greater than 0, that means the coefficient of x square, that is the leading coefficient, is greater than 0, and its discriminant, that is b square minus 4ac, is negative, then fx will be f of x, that is ax square plus bx plus c, will be always positive for all values of x belongs to R. For all x. So that's what precisely it has happened here. So you take this quotient and multiply by x square minus 8x plus 32. So the denominator will go off, and this is less than 0 will be retained. So you take that is less than 0 for all x belongs to R. Multiply if and only if ax square plus 2 into a plus 1 into x plus 9a plus 4 less than 0 for all x belongs to R, which is, let's call this inequality as number 1 inequality. Agreed. Now when this will be true, when this is again a quadratic, this is again a quadratic expression, because x square is there, quadratic expression. When will be, this will be negative for all x belongs to R. So let's now this is possible. Yes, this is possible if the coefficient, the leading coefficient, that is the coefficient of x square a, is negative and the discriminant is negative. If both these things are true, then this expression will be less than 0 for all x belongs to R. Let's look at the result. The result is if a less than 0, that is the leading coefficient is less than 0, discriminant, that is b square minus 4ac, is negative, then f of x, that is ax square plus bx plus c, will be negative for all x belongs to R. Yes, this is true. This is true. When this is possible? When a is less than 0, when this discriminant is 0. But you are asked to find how many values of a belongs to n. This is less than 0 for all x belongs to R. But this is possible only for when a negative, when a is negative. That means a is for no natural number. Every natural number is positive. For no natural number, this is true. Because this is possible only when a is negative. So that will tell you S is equal to a belongs to n. That expression less than 0 for all x belongs to R is true for none of them. Is true for none of them. For none of them. That means no natural number. Every natural number is positive. This is true when a is negative. But our S, in this S, a is a natural number. Therefore, for no natural number, this is true, because this is less than 0 for when a is negative. But we have to count how many how many natural numbers are there. For none of them. So therefore, this set is empty set. Therefore, n of s, the number of elements present is the number of elements present in the empty set, that is 0. So let's look at our options. Our answer 0 appears against option 4. Therefore, the answer to this question is option 4. And that is the detailed discussion of the solution of the problem from the section Quadratic Equations, and it is definitely an easy question. And I am sure that you have understood the solution of this problem, and we move on to the next problem, problem number 3. And this question has appeared in the 1st February 2024 in the first session, that is first shift. The given question is, let S is equal to the set of all those x belongs to R such that root 3 plus root 2 whole to the power of x plus root 3 minus root 2 whole to the power of x is equal to 10. And then the number of elements of S is, and 4 options are given to us. So that means now we are given S is the set of all those x belongs to the set of real numbers which satisfies root 3 plus root 2 whole to the power of x plus root 3 minus root 2 whole to the power of x is equal to 10. That means for how many real values of x this equation is satisfied. Then find out n of s. We now discuss the solution of the problem in detail. Right. We are given S, the set of all those x belongs to R, where R is the set of natural numbers, satisfying root 3 plus root 2 whole to the power of x plus root 3 minus root 2 whole to the power of x is equal to 10. What is root 3 plus root 2? Root 3 plus root 2 is a third. Right. Now, required to find n of s, we have to count the number of elements satisfying this one. So, let us suppose t is equal to root 3 plus root 2 whole to the power of x. And we see this root 3 minus root 2. Root 3 minus root 2. Who is this root 3 minus root 2? It is precisely 1 by root 3 plus root 2. This we know. And then 1 by t, if I write, then that will be 1 by root 3 plus root 2 to the power of x. Now, multiply both numerator and denominator by its rationalizing factor. What is the rationalizing factor for root 3 plus root 2? It is root 3 minus root 2. So, when you multiply, you will get this one. The denominator will be root 3 plus root 2 multiplied by root 3 minus root 2 is root 3 whole square minus root 2 whole square, that is 3 minus 2, that is 1. 1 to the power of x is 1. So, you will get root 3 minus root 2 whole to the power of x only. This is 1 by t is. 1 by t is. Let's go to the given equation. Root 3 plus root 2 whole to the power of x plus root 3 minus root 2 whole to the power of x is equal to 10. The first one is t plus the second one is 1 by t is equal to 10. So, this is multiplied throughout by t, then you will get a quadratic equation t, that is t square minus 10t plus 1 and is equal to 0. Now, solve for t, use the formula minus b plus r minus under the square root of b square minus 4ac by 2a, substitute the values, simplify, you will get 5 plus r minus 2 root 6. So, thus t will have, t will be, what is t? T is root 3 plus root 2 whole to the power of x, and that is, we have found out 5 plus r minus 2 root 6. We continue in the next slide. We have this, we have already seen. So, we have, so first root 3 plus root 2 whole to the power of x, let us take the first one, 5 plus 2 root 6 or root 3 plus root 2 whole to the power of x is equal to the second one, 5 minus 2 root 6. Let us take the first one. So, root 3 plus root 2 whole to the power of x is equal to 5 plus 2 root 6. And this is very well known. If you take root 3 plus root 2, square it, then you will get root 3 square, that is 3, plus root 2 square, that is 2, plus 2 into root 3 into root 2, that is 2 root 6. 3 plus 2 is 5, 5 plus 2 root 6. This is precisely root 3 plus root 2 whole square. The bases are same, the powers must be same, therefore x is equal to 2. Yeah, that is one value. That's one value. Take this one, second one, root 3 plus root 2 to the power of x is equal to 5 minus 2 root 6. So, this is the square of root 3 minus root 2. So, root 3 minus root 2 square. But we want the power of root 3 plus root 2. What is root 3 minus root 2? It is precisely 1 by root 3 plus root 2. So, this will be 1 by root 3 plus root 2 whole square. So, that will be root 3 plus root 2 to the power of minus 2. So, x will be equal to minus 2. So, you got two values for x. So, let us get into S. S is the set of all those x belongs to R which satisfies this equation. The values are only 2. Therefore, 2 comma minus 2. So, how many elements are there in this set? Only 2 elements. So, n of S, the number of elements present in S, is 2. So, the answer for this question is option 3. So, look at the options. So, option 3. So, the answer to this question is option 3. Option 3. So, that is the detailed discussion of the solution of the problem from the section quadratic equations, and I am sure that you have understood the solution of this problem. It is definitely an easy question. And let's now move to the next question. That is the last question in this session now. The fourth question. This question has appeared in 1st February 2024 in the second shift. The question is, let alpha and beta be the roots of px square plus qx minus r is equal to 0, where p not equal to 0. If p, q and r be consecutive terms of a non-constant geometric progression, and 1 by alpha plus 1 by beta is equal to 3 by 4, then the value of alpha minus beta whole square is, we are given 4 options. So, we are given a quadratic equation, px square plus qx minus r is equal to 0. We are given alpha and beta are the roots of this equation, and we are given p, q, r are the consecutive terms of a non-constant geometric progression, and alpha and beta satisfies this equation. 1 by alpha plus 1 by beta is equal to 3 by 4. Required to find the value of alpha minus beta whole square. Let's now discuss the solution of the problem in detail. We are given alpha and beta are the roots of this quadratic equation. We can write down the sum of the roots alpha plus beta is equal to minus the coefficient of x, that is q, by the coefficient of x square p. And alpha beta, the product of the roots, is equal to the constant term, that is minus r, by the coefficient of x square, that is p. Agreed. Agreed. We will use the other condition. We are given p, q and r are consecutive terms of a non-constant GP. So, we can write down, we have already studied in our earlier classes. We take p is equal to a times s, where s is the common ratio, q is equal to a, r is equal to a by s. Yes, 3 consecutive terms, if they are given, we will take like this. S is the common ratio. Normally R is the common ratio, but that R is appearing in this equation. Therefore, there will be a clash in understanding things. Therefore, we have taken another letter for the common ratio, that is S. Agreed, agreed. Now, we go to alpha plus beta. Alpha plus beta is equal to minus q by p. What is q? Q is a minus a by p. P is a, yes. A cancels, and that will be minus 1 by s. Now go to alpha beta is equal to minus r by p. That is equal to minus r is a by s by p a s. A cancels. This will be minus 1 by s square. Agreed. Agreed. Now, we are also given the relationship between alpha and beta that we will utilize now. 1 by alpha plus 1 by beta is equal to 3 by 4. Take the LCM. Alpha plus beta by alpha beta is equal to 3 by 4. And look at the previous one. Alpha plus beta is minus 1 by s from here by alpha beta. Alpha beta is minus 1 by s square here is equal to 3 by 4. So, minus minus goes off and you will get S is equal to 3 by 4. S is equal to 3 by 4. Agreed. Now, what is to be found? We are asked to find out what is the value of alpha minus beta whole square. And we have the identity. alpha minus beta whole square is equal to alpha plus beta whole square minus 4 alpha beta. Yeah, very well known identity. And alpha plus beta whole square. What is alpha plus beta? Minus 1 by s whole square minus 4 times alpha beta. Alpha beta is minus 1 by s square. Write down. That is minus 1 by s whole square minus 4 times minus 1 by s square. This is 1 by s square. This is plus 4 by s square. 1 by s square plus 4 by s square is 5 by s square. And we know the value of s. S is equal to 3 by 4. So 1 by s is 4 by 3. So this is 5 into 1 by s square is 4 by 3 whole square. Multiply 5 into 16 by 9. Multiply 80 by 9. Let's look at our options. Our answer 80 by 9 appears against option 1. Therefore, the answer to this question is option 1. And that is the detailed discussion of these 4 questions, multiple choice questions on the topic quadratic equations, which are asked in the JEE Main examination in the January 2024 session. And these are all easy questions. I am sure that you understood the solution of this problem, and I wish you all the best. Thank you.